This lesson's Unit 1, Section 1, Day 3. We are now section in the textbook 4.3. So we're going to start with a little division, but we're going to do some long division here, right? Old school style. So if you remember, we put the first number inside, and the second number goes outside. So what we're looking for is how many times 48 goes into 1. That's none. How many times 48 goes into 18? Also none. So now I go 48 into 182. So this is about 50. So I'm going to estimate how many times does 50 go into 182, and that would be about 3 times. And if you recall now, we do 3 times 48 and write that number underneath. So 3 times 8 is 24, carry the 2. 3 times 4 is 12, plus 2 is 14. So now if you remember, we subtract. So 2 minus 4, or 12 minus 4 is 8. This is now a 7. 7 minus 4 is 3. If for some reason this number was bigger than 48, I'd have to go back and change this, right? So now I have 38, and I'm going to bring down the 7. So now I want to know how many times does 48 go into 387. So this is almost 400, right? And this is 50. So let's say it's 8 times. Let's see how that works. So 8 times 8 is 64. Carry the 6. 8 times 4 is 32. Plus 6 is 38. All right, that did pretty well there. So we're left with 3. Now, there's 2 ways we could look at this. I could put the point 0 and bring the 0 down and keep trying. Or I could say it went in 38, and my remainder was 3. So that's 3 out of 48. Or 38 and 1/16. But the important thing to remember is that this was the remainder, and it goes over what we were dividing by. The reason we're talking about this is because we're going to start dividing polynomials. So if I wanted to divide these polynomials, I'm going to set it up the same way I just set up that other numerical long division. Let's get some smaller lines here because we're going to have a lot going on. So the first number is the one that goes, let's try that again, that goes under. So that's going to be the 2x to the 4th plus 3x cubed. I need to put a placeholder there, 0x squared plus 5x minus 1. And what we're dividing by goes on the outside. So what I'm going to start with is I'm going to figure out, I'm only going to look at first terms right now. The first term is 2x to the 4th. The first term is x squared. What do I have to multiply x squared by to become 2x to the 4th? So first we have a 1. So 1 times what gives us 2 is 2. And then I have x squared. So what times x squared gives me x to the 4th? X squared. So I know my first number I'm going to use is 2x squared. So I'm going to line that up over my x squareds. So same as long division went before, I'm going to take this term and I'm going to multiply it by the whole thing. So 2x squared times 1x squared is 2x to the 4th. 2x squared times 3x is plus 6x to the 3rd. 2x squared times 2 is plus 4x squared. So just like before, we're going to subtract now. But since I have multiple parts, we're subtracting each one. So those canceled. 3x to the 3rd minus 6x to the 3rd was negative 3x to the 3rd. 0x squared minus 4x squared is negative 4x squared. I'm going to bring down the next part, plus 5x. So now I'm looking at, what do I have to multiply x squared by to get negative 3x to the 3rd? So 1 times negative 3 is going to give me negative 3, and x squared times x is going to give me the x to the cubed. So now we're going to take negative 3x and multiply it by everything there. So we get negative 3x to the cubed, or negative 3x cubed, we get negative 9x squared and negative 6x. So just like last time, we're going to subtract, but now I have to change all the signs again. So that's really a plus, that's really a plus, that's really a plus. So we're going to cancel those. This becomes 5x squared, and this becomes plus 11x. Bring down the negative 1. So last, we're going to figure out what do I multiply x squared by to get 5x squared, and that's a positive 5. So again, we'll do all our multiplication. 5x squared plus 15x plus 10. And we'll subtract one last time. Subtract, subtract, subtract. Those canceled. We're left with negative 4x and negative 11. This is our remainder. So the way we would write our answer is this polynomial. Let's go a different color now. So 2x squared minus 3x plus 5 plus my remainder over what I divided by. So that's negative 4x minus 11 over what I divided by, x squared plus 3x plus 2. So this would be the answer for this polynomial long division problem. Now I've got some good news for you. I'm not going to make you do long division. We're going to be using synthetic division, much like the synthetic substitution that we learned about on day 1. The only difference is synthetic division can only be used if you're dividing by a linear term, which means there cannot be an x squared in the problem. But that's okay. That's what we're going to do. So because when we evaluate a number, the number at the end is what it was equal to, right, when we did synthetic substitution, the remainder is now equal to the value at that problem. So what we're going to do, all right, I just said it only works when we're dividing by a linear term. We're going to find out what x equals by setting the linear term equal to 0 and solving, right? So that means we're going to end up usually the negative number, right? If it was x plus 4, that means x equals negative 4. We're going to use synthetic substitution using that value, and we're going to use the numbers all the way across the bottom to write as a polynomial with its remainder. We're always going to end up starting 1 power lower than what we started with because we took out a power of 1. I know that sounds like a lot, so let's look at what that looks like in action. So here we have x plus 1, which if I set up x plus 1 equals 0, I get x equals negative 1. So that's the value I'm putting on the outside of my synthetic problem. Then I'm going to put the numbers across the same as I did for synthetic substitution. So if there's any term that's missing, I have to put the 0 there. We have 3, 2, 1, 0. We don't have to put any zeros in place. So 3, negative 2, 2, negative 5. If you recall, we bring down the first term, and now we start the multiplying. So we have negative 1 times 3 is negative 3. We get negative 5. Negative 1 times negative 5 is positive 5. We get 7. Negative 1 times 7 is negative 7. We get negative 12. So since this started as an x to the third, I'm going to start writing my answers as x squared, x, the constant, and the remainder. So what this turns into is 3x squared minus 5x plus 7 plus the remainder of negative 12 over the thing I divided by, x plus 1. So this is actually the answer for this division problem. Try another one together. So here, if I'm dividing by x minus 3, we get really positive 3. That's going to go on the outside. I have 3, 2, I'm missing something, and then 9. So that means I'm going to use negative 1, 4, 0, and 9, right? Placeholder for that x term. So 3 times negative 1 3 times 1, 3 times 3, and there we go. So this time, 1 less than x cubed is x squared. That's our x term. That's our constant. That's our remainder. So that's going to be negative x squared plus x plus 3 plus 18 over x minus 3. Okay? You guys try the next two. Pause it and I'll show the answer. All right, check those answers. The last thing we're going to do for this, we have a bit of a word problem here. The volume of the rectangular prism is given by v equals this polynomial. We want to find an expression for the missing dimension. So since we know that volume of a rectangular prism is length times width times height, we are going to take out the height and the width to find the length from the entire thing. So what that means is I'm going to divide one part at a time. So I'm going to start by taking out the x plus 2, which means I'm really using a negative 2. So I'm going to put negative 2 on the outside, and now 2, 17, 46, and 40. So I'm going to bring the first one down, and I'm going to start. So we get 13, negative 26, we get 20, we get negative 40, and 0. So something we haven't talked about yet is if the remainder is 0, that means the term was actually a factor of the polynomial. So we always are looking for 0 for it to be a factor of the polynomial, and we'll get into that in later sections. So what this means for us is now I'm going to take these three and make a new problem, but now I'm going to use the negative 4 from x plus 4. So I'm just going to use these three. Right? I've already taken out the x plus 2 using negative 2. This is the remaining polynomial. Now I'm going to take the x plus 4 out of this polynomial. So we get negative 8, 5, negative 20, 0. So again, x plus 4 was in fact a factor of that. So what I'm left with is now I've gone down from x cubed. This first part was x squared, x constant. And now I went down one step further. So instead of x squared, it's x and constant. So my answer would be 2x plus 5. That was my missing expression. All right, and that is it for dividing polynomials.